they had my mind absolutely, completely blown, because if you think about async statements and async workflow, it's practically a go-to. How you had older languages which evolved out of assembly, because it's assembly, it's just exactly how you structure the computer code, how it's executed in just mapped one to one. So it's the most reasonable abstractions to take when representing it. So before the concepts, all the concepts that modern languages take, even having the concept of scopes, anything else, the computers do work like the first languages. I don't remember the names of these languages, but the point is we have goto statements which just redirect you to correct place in a file with bunch of lines. And even when it evolved away from assembly and exec instructions, it was still a bunch of macros on them, and then go to statements or jump to statements to go around them. And that's actually where the term spaghetti code originated, because you could have like 15 lines and then effectively 12 go to transactions, and it's incredibly difficult to reason about. And immediately, you cannot write code past the point where you're able to keep the entirety of the project in your mind, because anything can have a go-to statement, and go-to statement can go anywhere. And so you do not have the directionality of the control flow, because you can go to do some function, and if the language even has the goto statements, the function could do anything. It could never return. It could go to like different place and another different function and in the inside of for loop whatever, and then return from yet another function in a completely different place. It can happen. It can happen, and that's initially the go-to statements were the only control flow available, and then at some point were introduced like for/while loop, which is basically like you have the go-to, which is like you have the control, and the go-to just puts it anywhere else, right? You have for loop, which you have like control, and it kind of loops on it and then passes it forward. You can have a function which just redirects it in. The point is, all of these operations, like if else, it kind of splits the control flow and then joins them back. The point is, you know exactly where you will get ownership of the control flow back. And this by itself was not a solution, and only with Jikistras, I still have no idea how to pronounce it, his weird name, but he originated so many incredible ideas, and it's basically the man who solved the go-tos. And at the time, I think it was like 60s, 64 maybe, no idea, I don't remember dates. Point is, many programmers defended the go-tos with all their might, because the people who were proficient at writing this type of flows, thinking in this way, and there's already a lot of infrastructure built around this. And this man just came in and said, let's introduce new bunch of primitives, and instead of thinking about them as macros on the go-tos, because initially programmers thought about the loops or if-else statements or functions, whatever, as just macros around goto statements. But what ended up being the correct solution to solve the problem fundamentally was to exclude the goto from the language altogether. And then when there is no ability to do goto, or when we have domesticated version of the goto, which cannot get outside of the scope it was called in, which still some languages have, like I think C#, Go, CPP. all the current languages that currently have the goto statement, it's very contained, and that solved everything because you could be sure about guarantees of the code which you did not write or that you wrote, but is too large to hold in the memory, in your memory in its entirety. And just allowed to think as a black box because you know exactly where you get by the control. And now think about the async code. And again, none of these are my ideas. I just read a bunch of very smart people just now and had a little existential crisis. So if you think about async code, it's basically you can jump anywhere. You can spawn a task which will just do whatever. And you can spawn a task with anything. And it may not terminate when the current scope closes. Like Rust solves some of this by default because of its ownership model. But if you take like Python's async IO or JavaScript or whatever else, it's just a hot soup of different tasks which are all mixed together, and then by default you are not allowed to preempt to do preemptive freeing of them. So you must introduce things like jails and so on. And but no matter how structured today, there is no languages with solution that fully covers this problem because while goto statement can kind of transfers control flow to a random point in the program, async function does the same, but then also continues the current control flow if you need it. But in fact, there's no fundamental difference between the problems that goto statement has and the async stuff, which and it is actually not necessarily trivial, but we have examples of how it can be solved from goto, and we actually have the repetition of the exact same problem with people fighting for the original format or not even being aware of changes that could be made. And it makes sense because representing the async tasks as they're represented currently in practically all the languages besides maybe Golang and Kotlin is the first primitive you reach for because it is how fundamentally the compiler works. This is fundamentally what is happening on a lower level, same as goto, because the binary does not have your machine does not have for loops in it. I mean, we have some like primitive macros, whatever, but everything compiles down to be like a bunch of goto statements, effectively. So there it was the first primitive to reach for, and here with async code, it's also the first primitive to reach for because it's how it works fundamentally. One solution that is there is the trio library for Python, which defines a concept of nurseries, which is a new concept. And when I first saw it, it also was kind of bizarre because why would we need it? But now having existential crisis, and I think it must be the default way of doing things, and we must remove the standardizing models from languages. Because it could simplify so much. It just simplifies so many things. So basically, nursery would kind of create a scope in which you can define as many tasks as you want, and then just have like start soon on them, call start soon on them, and then something happens, and I do the magic. But none of these tasks are allowed to run past the yielding of the nursery. So as soon as nursery closes, nothing inside it can continue running. So nursery by default just awaits for all the tasks to finish. And it's kind of the so the new child process is also nested inside it, and then you still have the full expressivity of the async models by just passing this nursery around. You can pass it into different function, and then make operations on it there, right? And the implementation is not actually more difficult than how by default async is managed, or maybe like slightly more difficult. The runtime cost is practically the same. There are additional bytes you need to keep for a few things, but it's negligible. And most importantly, it renders completely unnecessary most of the features that around async that language acquires, because when in the beginning, when you need async, none of the language maintainers reach for changes in C syntaxes. They first start trying to do what like how it works fundamentally, and then just trying to implement on top of it, because when you make a change of that size, you want to first implement a library, and then you implement a library, and because by default, again, you don't have the syntactic support for what you're trying to do, it's kind of all quirky. It doesn't work exactly as you want it to, and you must over-engineer it, and then you have all this complete mess of the concepts, and then you realize that this doesn't work. You go back to the language, but at this point you've already spent like years on this problem, and you have a full, well, at least months, say, and you have tunnel vision on trying to implement this higher level, not higher level, but like trying to make things work within the existing model. And when even if you made changes to the code syntax after that, you would normally be trying to just make your libraries work by doing this, instead of making the async implementation from zero. Anyways, this is a huge problem, and I don't think Rust will adopt the what I now believe is the correct model of async at any point in time, because that would just require rewriting everything. And honestly, I think Rust is gonna end up same as CPP, because well, it's just the natural progression of such things. So probably at some point the new language will come, which will by default think about this. And so I don't think the time I spent learning Rust was useless, and today, it is still the best choice for many, like more than half of the things I'm doing. So investment in it was definitely great, and I will still continue investing in it. But it is so sad to know that some parts of it are just glaringly suboptimal. Yeah, and I am absolutely certain that Rust eventually will go down the same path as CPP, because first of all, it's the same things as same direction that Rust is taking. That's like Rust from CPP, as CPP went from C. Same kinds of problems. The first change in CPP introduced, the very first, was ensuring as a property that exceptions will always be omitted. And so you at least you had like one thing you could be sure of, and then with time more and more safety was added. More and more like checks, support for tuning systems, and Rust is going in this direction. And there was already too many features that do not need to exist, like first or last on array. What the hell is wrong with .get0 or .add0? It's just and it's kind of enforced by the Rust conventions. And these are just additional methods for the sake of additional methods. And more people will do things different ways. And then you have so many ways to do things and so little testing effectively on each, especially when you start combining them. As soon as something has a side effect, even like 2 or 3 levels, no matter how large the Rust ecosystem is already enough to put you on a very, very poorly trodden paths when you reach for these methods. And this is a huge problem, and it will only be growing. There's just no movement for deleting things from the language, and so it's just eventually it's also gonna become uploaded as C++ is today. But it will take time, and well, anyways, I think as this today is a mess, and apparently it can be solved so easily by applying the same principles as once helped solve the goto problem. And this will not let me sleep this night.